Today we are going to discuss a new topic, electric dipole. Simply, you consider a pair of charges equal and opposite, separated by a small distance. And such an arrangement of a two-charge system is called an electric dipole. Equal and opposite charges separated by a small distance is called an electric dipole. Electric dipole ലെങ്തിനെ ഒന്നാമത്തെ ചാർജ് തുടങ്ങി രണ്ടാമത്തെ ചാർജ് വരെയുള്ള ലെങ്ത് we will call it as the dipole length. Usually 2a എന്നാണ് നമ്മൾ റെപ്രസെന്റ് ചെയ്യാറ്. See, 2a എന്ന് റെപ്രസെന്റ് ചെയ്താൽ half of the length we can take a and the remaining of again a, and see this distance is measured from negative to positive. എല്ലായ്പ്പോഴും നെഗറ്റീവ് തൊട്ട് പോസിറ്റീവ് വരെയാണ് ഡൈപോളിന്റെ ലെങ്ത് മെഷർ ചെയ്യാറ്. and it's a vector starting from negative to positive. See, the property of this dipole is characterized by a quantity called dipole moment. Dipole moment is defined as either of the charge. Q is the charge, this is minus Q and this is plus Q. Dipole moment is defined as either of the charge into the length of the dipole. So we can write P equal to Q into 2A. And I told you 2 is measured from negative to positive and is a vector. So Q is a scalar and Q into 2 is a scalar into vector is definitely a vector. So the dipole moment is a vector. What about the unit? Q is measured in coulomb and 2A is measured in meter. So the unit is coulomb meter. In our coming cases, we will deal with an ideal dipole. Dipole ideal ആവാന്ന് പറഞ്ഞാൽ see, ചാർജ് വളരെ വലുതാവുക, ലെങ്ത് വളരെ ചെറുതാവുക, അപ്പോഴാണ് നമ്മൾ ഡൈപോൾ ഐഡിയൽ ആവാന്ന് പറയാം. An ideal dipole is one with large charges separated by a small distance. See, ഈ ഡൈപോൾ ഇവിടെ വെച്ചിരിക്കുകയാണെങ്കിൽ around this dipole there will be some electric field. നേരത്തെ പോലെ ഒരു സോഴ്സ് ചാർജ്, സിംഗിൾ ചാർജ് പോലെയുള്ള ഇലക്ട്രിക് ഫീൽഡ് ആയിരിക്കില്ല. സപ്പോസ് ഐ എം കൺസിഡറിങ് എ പോയിന്റ് ഹിയർ, ഇതുകൊണ്ടുള്ള ഇലക്ട്രിക് ഫീൽഡ് ഉണ്ടാവും, ഇതുകൊണ്ടുള്ള ഇലക്ട്രിക് ഫീൽഡ് ഉണ്ടാവും. We have to use superposition principle. ഈ ഡൈപോളിന്റെ എല്ലാ ഭാഗത്തും ഉണ്ടാവും. നമ്മൾ രണ്ട് സ്പെഷ്യൽ കേസ് എടുക്കാൻ പോവാം. See, this is my dipole, minus Q is here, plus Q is here, and the length of the dipole is 2a. See, ഈ രണ്ട് ഡൈപോളും കണക്ട് ചെയ്യുന്ന ഒരു ലൈനിനെ we can call it as axis of the dipole. And a line passing through the axis of dipole is known as axial line. ഞാൻ ഈ ഡൈപോളിന്റെ ആക്സിയൽ ലൈനിലെ ഒരു പോയിന്റ് കൺസിഡർ ചെയ്യാൻ പോവാണ്. Let P be the point on the axial line of the dipole. And I will say the point P is at a distance r away from the dipole. Dipole എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ from the center of the dipole ആണ് നമ്മൾ മെഷർ ചെയ്യേണ്ടത്. r away ഒരു പോയിന്റ് കൺസിഡർ ചെയ്തു. And we are going to find out the electric field at this point P. ഇവിടുത്തെ ഇലക്ട്രിക് ഫീൽഡ് രണ്ടെണ്ണം ഉണ്ടാവും. മൈനസ് Q കൊണ്ടൊരു ഇലക്ട്രിക് ഫീൽഡ് ഉണ്ടാവും, പ്ലസ് Q കൊണ്ടൊരു ഇലക്ട്രിക് ഫീൽഡ് ഉണ്ടാവും. Minus Q under the electric field it will be towards the dipole, and the plus Q under the electric field away from the dipole. And I have represented the electric field due to negative as E minus and that due to positive as E plus. See, what about the magnitude of E plus? E plus ആണെങ്കിൽ ഇവിടുത്തെ ചാർജ് Q ആണ്. 1/4 epsilon 0 this charge divided by this distance. This distance എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ the total distance from the center to this point is r and this distance is a. So ഇവിടെ തുടങ്ങി ഇതുവരെ ഡിസ്റ്റൻസ് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ ടോട്ടൽ ഡിസ്റ്റൻസ് r എന്ന് ഈ ഡിസ്റ്റൻസ് a മൈനസ് ചെയ്താൽ മതി. So we can write E plus equal to 1/4 epsilon 0 Q by r minus a the whole square. Similarly minus Q കൊണ്ടുള്ള ഇലക്ട്രിക് ഫീൽഡ് ആണെങ്കിൽ ചാർജ് മൈനസ് Q ആണ്. The length is this point to this point എന്ന് വെച്ചാൽ സെന്റർ തുടങ്ങിയിട്ടുള്ള പോയിന്റ് r ആണ്, ഈ പോയിന്റ് a ആണ്. The total distance is r plus a. So we will write E plus equal to minus 1/4 epsilon 0 Q by r plus a the whole square. Remember there is a negative sign because the charge is negative. അപ്പോൾ ഒന്ന് ഇവിടേക്കുള്ളത് പോസിറ്റീവ് ആയിട്ട് എടുക്കുകയാണെങ്കിൽ തിരിച്ച് E മൈനസ് നെഗറ്റീവ് ആയിരിക്കും. ഇവിടെ വെക്ടേഴ്സ് ആണ് രണ്ടും, ബട്ട് I haven't wrote the direction here, but I told you the direction എവിടേക്കാണെന്ന് പറഞ്ഞിട്ടുണ്ട്. Now, ഇതിന്റെ റിസൾട്ടന്റ് കണ്ടുപിടിക്കാൻ you can simply take the algebraic sum as the dipoles are acting on a straight line. So the resultant field E equal to E plus E minus. E plus is 1 by 4 pi epsilon 0 q by r minus a the whole square, minus the second one 1 by 4 pi epsilon 0 q by r plus a the whole square. This quantity 1 by 4 pi epsilon 0 into q is common in both, and I will take it outside. And here is 1 r minus a square, here is r plus a square, that will be the LCM r minus a square into r plus a square. Now in this you can write r plus a square minus r minus a square by r minus a square into r plus a the whole square. This is simple mathematics, and we can simplify it. Expanding the r plus a square and r minus a square, we will get the quantity q by 4 pi epsilon 0 is there, then r square plus 2ra plus a square minus of r square minus 2ra plus a square. Again, taking this negative sign into the bracket, r square plus 2ra plus a square minus r square plus 2ra minus a square. Say this r square cancels, a square cancels, 2ra, that is 4ra. And remember one thing, here I have taken this square outside the bracket. So I can write r minus a into r plus a the whole square, and the quantity inside this bracket, this is in the form a plus b into a minus b, is nothing but a square minus b square. So in the next step, I would write q by 4 pi epsilon 0 4ra by a square minus b square, formally written r square minus r a square the whole square, and that is equal to see 1 by 4 pi epsilon 0 is there, and I am taking the q inside. I can write q2 into q into 2a into r, the same as 4r q4ra divided by r square minus a square. See, what is the quantity inside this bracket? It is something about the dipole moment that we have already defined. So we can write this is equal to 2 in 1 by 4 pi epsilon 0, 2 into p, this is dipole moment, p r divided by 4 pi epsilon 0 r square minus a square the whole square. So we calculated the electric field due to a dipole on its axial line at a point P. Let's consolidate our result. E equal to 1 by 4 pi epsilon 0 2 pr by r square minus a square the whole square. See, suppose my dipole is an ideal one. That means charges are large and the distance 2a is very small, or a is very small compared to r. So I can say if r is much greater than a, my dipole is ideal one, then a can be neglected. My equation becomes 1 by 4 pi epsilon 0 2 pr by r square the whole square. It's nothing but 1 by 4 pi epsilon 0 2 pr by r raised to 4, and the r and 1 r of this power 4 cancels, and I will get 1 by 4 pi epsilon 0 2 p by r cube. So for an ideal dipole, the electric field on the axial line E axial is equal to 1 by 4 pi epsilon 0 2 p by r cube. So this is the electric field due to an electric dipole on its axial line. See, now we will find the electric field due to a dipole on its equatorial line. See, this is my dipole, the same as we have taken in the previous case, minus q and plus q separated by a small distance 2a. And if I take the midpoint of this axis and drawing a line perpendicular to that axis, this line is now called equatorial line. And now I am considering a point on this equatorial line P at a distance r away from the dipole, and we need to calculate the electric field at this point. For that, we need to know the distance from minus q to p and place plus q to p. So I'm completing my figure. Let this angle be theta and this angle be theta. Now I want to know the distance between this point P and minus q. Similarly, the distance between the point P and plus q. So you can simply use the Pythagoras theorem. This is a, this is r. Therefore, this is root of a square plus r square. I can write this distance is root r square plus a square. See, now there will be an electric field due to this charge q acting in this way I can represent it as E plus, and similarly E minus will be acting towards the negative charge like this. Now the electric field due to the plus charge can be written as 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, this charge Q divided by this distance squared. This distance is root of r square plus a square, where I am taking the square, the root cancels, and I can write 1 by 4 pi epsilon 0 Q by r square plus a square acting away from the charge Q. And similarly, for the charge minus Q, the electric field is acting towards the charge minus Q and is given by E equal to 1 by 4 pi epsilon 0 Q by r square plus a square. Again, the distance is root of r square plus a square. Taking the square, the root cancels, we get this quantity minus 1 by 4 pi epsilon 0 Q by r square plus a square. When you look at the values, both are acting in different directions, but the magnitude are same, or magnitude wise I can write the magnitude of E plus is equal to magnitude of E minus. See, this is a horizontal line parallel to this axis. Therefore, if this angle is theta, this angle is theta. Similarly, this angle is also theta. Now I am going to resolve this vector E plus into two components, a perpendicular component and a horizontal component. Horizontal component, parallel component. See, this component is E plus sine theta, and this component is E plus cos theta. We know from the vector solution principles. Similarly, the negative charge acts the field in this direction, and we can resolve it as one along this component, along this line, and other component is along this way. So the downward component is E, horizontal component is E minus cos theta, and the downward component is E minus sine theta. And see one thing, E plus and E minus are equal in magnitude. Therefore, we can say E plus sine theta and E minus sine theta cancels. So we don't have to bother about those components. So what contributes to the electric field at this point P is E cos theta in this way, and again E minus cos theta in this way. So we can say the electric field E equal to E equatorial equal to E cos theta plus E minus cos theta is 2 times E plus cos theta. You know, E plus cos theta, E plus and E minus are equal, so you can write like this. And substituting for E plus, we will get 2 times 1 by 4 pi epsilon 0 Q by r square plus a square into cos theta. What is theta? Cos theta. Let's see. See, in this triangle, cos theta equal to a by root of r square plus a square. So we can substitute back to this equation. We will write, instead of cos theta, you can write a by root of r square plus a square. You will get 2 into 1 by 4 pi epsilon 0 Q by r square plus a square into a by r plus root of r square plus a square. See, you can write r square plus a square raised to 1 by 2 instead of this root. So I will get like this, 2 into 1 by 4 pi epsilon 0 Q by r square plus a square into a by r square plus a square whole raised to 1 by 2. And this is whole raised to 1 and this is whole raised to 1 by 2. I can multiply both. I will get 1 by 4 pi epsilon 0, Q is the a, 2QA divided by 1 plus 1 by 2 is 3 by 2. So I will get 1 by 4 pi epsilon 0, 2QA by r square plus a square whole raised to 3 by 2. Again, this quantity is familiar to us. It is nothing but the dipole moment, and I will get 1 by 4 pi epsilon 0 P by r square plus a square whole raised to 3 by 2 is the electric dipole moment on its equatorial line at a point P. See, we can consolidate the result as E equatorial equal to 1 by 4 pi epsilon 0 P by r square plus a square whole raised to 3 by 2. And what if my dipole is an ideal one? Ideal one means the distance A is much less than the distance R. The length A is much less than the distance R. We can say R is much greater than the distance A. See, let us assume the case, and I can be neglected. So we will get 1 by 4 pi epsilon 0. here it is r square all raised to 3 by 2. We can write p by r cube. So we will get on the equatorial line of an ideal dipole, the value is like this. Equatorial equal to 1 by 4 pi epsilon 0 p by r cube. Now, see one thing. This is our dipole, and at a point r on the axial line, we get the electric field E axial equal to 1 by 4 pi epsilon 0 2 p by r cube. And suppose I am considering a point at the same distance r on the equatorial line, like this. The distance r is same. Now, the electric field at this point is given by the equatorial equal to 1 by 4 pi epsilon 0 p by r cube, and I assume that my dipole is an ideal one. Suppose I am taking the ratio of the electric field at this point to this point, I'll get the axial by E equatorial equal to 1 by 4 pi epsilon 0 2 p by r cube, and it is 1 by 4 pi epsilon 0 p by r cube, and I will get 2. This is a subject problem that we should have for examinations. That's all.